Up to now, we've mostly treated the broker as a pipe, something that moves messages from A to B. This episode, the broker becomes something more, a substrate for computation. This is stream processing, processing events as they flow, in real time, instead of in nightly batches. It's the advanced end of the log model, and it's where some of the most impressive systems you've used are built. Let's get into it. First, batch versus stream, so the contrast is clear. Batch processing works on bounded data, a file, yesterday's dump, with latency measured in minutes or hours. It answers the question, what happened yesterday? Stream processing works on unbounded data, a never-ending flow of events, with latency measured in milliseconds to seconds. It answers, what is happening right now? A stream processor continuously consumes a topic, transforms or aggregates or joins the data, and emits results to another topic or store. To think clearly about streams, you need two core abstractions, and the relationship between them is the key insight of the whole field. The first is a stream. It's an unbounded sequence of independent events. Every record is a fact. This happened. The second is a table. It's the latest value per key, a materialized view that updates as new events arrive. And here's the beautiful duality. A stream, aggregated by key, becomes a table. And a table's log of changes is itself a stream. Streams and tables are two views of the same thing. Hold on to that. It's called the stream-table duality, and it's the mental model that makes everything else make sense. Now, the real value in stream processing comes from state. Counts, sums, joins, deduplication. All of these require remembering things across events. So the processing engine keeps a local state store right next to the consumer, often backed by an embedded database and backed up to a changelog topic so it survives restarts. And local is the magic word. Because the state lives right there with your processor, lookups and joins hit local memory or disk, not a network call to a remote database. That's what makes real-time enrichment possible in single-digit milliseconds. But there's a requirement. To join a stream and a table locally, they have to be co-partitioned. Same key, same number of partitions, so that matching keys land on the same processor instance. Get that wrong, and your joins silently miss data. Next, the concept that makes streaming tricky and interesting: windowing. You can't sum an infinite stream. It never ends. So you bound it into windows. There are three types worth knowing. Tumbling windows are fixed and non-overlapping, count per 5-minute bucket, 0 to 5, 5 to 10, and so on. Hopping windows are fixed size but overlapping. Every 1 minute, look back over the last 5. And session windows are gap-based and dynamic. Group a user's activity until they've been quiet for a few minutes. A classic use? More than 10 events for the same key within any 5-minute window. That's a velocity or anomaly rule, and it's a tumbling window count with a filter on top. Then there's the messy reality of time. There are two clocks. Event time is when something actually happened, recorded in the message. Processing time is when your engine got around to seeing it. For correctness, you almost always want event time. But events arrive out of order. Network delays, retries, a phone that was offline reconnects. So you use a grace period, or a watermark, which waits a bounded amount of time for stragglers before finalizing a window. It's a trade-off. A longer grace period is more accurate, but slower. A shorter one is faster, but might miss late data. Finally, the toolbox, what you'd actually use. Kafka Streams is a library that runs inside your own application, no separate cluster. Great when you're Kafka native, on the JVM, with moderate complexity. KSQLDB lets you write SQL over Kafka Streams, perfect for quick transforms without writing code. Apache Flink is a standalone, extremely powerful engine with first-class event time handling, exactly once, and huge state. Reach for it at high scale or on non-JVM stacks. And Spark Structured Streaming brings streaming to teams already on Spark, unifying batch and stream. Here's the framing that lands in interviews. Kafka Streams is a library, so there's no extra cluster to run. The state is local and co-partitioned, which makes enrichment and windowed aggregations fast. For very large state or advanced event time semantics, I'd reach for Flink. So that's stream processing, streams and tables, local state, windows, and event time. The broker isn't just moving your data anymore, it's the foundation you compute on. Next episode, we start putting everything together, building a complete order processing pipeline from scratch. See you there!